Hello and welcome to part 2, the second video on aircraft power electrical generator controls. The first part we talked just basically about the need for control and the voltage regulation. There's a few other things we have to control and we'll go into those in this video. The first thing is our problem of reverse current. Reverse current happens when, if the voltage in the battery is greater than the voltage of the generator. For example, if the engine's off, the battery will still be at 12 volts, the generator will be at 0 volts. If I had that happen, my current flow would be through the generator. And I wouldn't really care for that. Even if my generator, let's say it wasn't off, let's say the engine's running, but if the generator is not making electricity yet, not up to full rated capacity, even if it's 9 volts, I still have current going out of the battery into the generator. And I don't like that. It causes problems. With the engine off, of course, it'll drain the battery pretty quickly. And even with the engine on, what would happen is with a low voltage here and the current flowing through, it would drain the battery fairly quickly rather than be charging the battery. So what we do in order to prevent this is we have a reverse current relay, or sometimes called a cutout relay. So here, current will try to flow, and if the generator is not producing enough voltage, the relay remains open. Once the generator produces enough voltage, this relay closes, and now instead what we have going on is current flowing from the generator to the bus and then actually back into the battery to charge the battery. And that's what we want to have happen. So let's take a look at how we do this. There's a lot of different ways to do it. This is the way done with the old mechanical regulators that you'll see in your old high-wing Cessnas and Super Cubs, things like that. We use a reverse current relay. And basically, here's my generator right here with the armature lead and the field. I just drew this voltage regulator. Know that that's a similar circuit to what we talked about in the first video. So the generator, when it's producing current, it's going to go through this reverse current relay, which has two coils. It has a current coil and a voltage coil. And the voltage is going to try to go this way. It's also, you'll notice, going to flow here, and we're going to start getting a little magnetism in this direction. Once we get enough magnetism, once this voltage level has reached enough, if it's a 12-volt airplane, we'll say at 12.5 volts or so, this will close. And then I can go out to the aircraft system. Note that, like I said, this voltage coil is in parallel with the generator, and the current coil is in series. So completing what we got here, if the voltage of the generator goes up, the voltage of the voltage coil will go up, the relay close, the current of the generator will flow to the bus. Now, when I get the situation of the generator becoming less than the battery, the current through this coil right here, the current coil, decreases. The magnetism will decrease. When the magnetism decreases, my relay will open back up. So it's pretty simple how that works. Here is our basic 2-unit regulator. We've got our voltage regulator side and our current regulator side. This will all be in one housing, one metal housing, usually on the firewall, and the spring force for each relay can be adjusted. In other words, there's a little spring that holds this relay and holds this relay. If I tighten this spring, it'll take more current through here in order to close the switch. And the same here, if I tighten this spring, take more current flow here to close this switch. This was our voltage side, and this is the reverse current. So if I take the reversed current spring and I make it stronger, then the generator voltage, the required generator voltage, will have to be higher. It doesn't make the voltage higher, it's going to make a higher voltage to close that relay. And the same thing erase this. If I look at the spring on the voltage regulator, if I tighten that spring, then what's going to happen is my generator voltage will actually increase. It actually does increase. What happens is with this spring tighter, it takes more voltage for these coils to pull this switch and bring it back down. That is how we adjust them. And here is our last regulator. This is more common. This is our 3-pole regulator. In the 3-pole regulator, we've added another relay, the current sensing relay. So here's our current sensing relay. We've got our old voltage sensing relay, and then here's our reverse current relay. And in this kind of case, so the reverse current relay, remember, is 2 coils, 1 series, 1 shunt or parallel. The current sensing relay is series, and the overvoltage is shunt. So normal operation, current's coming out of my generator through this coil, through here, and once my voltage has gotten up enough where this can close, out to my aircraft bus. Pretty simple. Let's take a look at the over voltage condition first. If I'm in an over voltage, again, I'm flowing through here. It's going here, but now notice my over voltage coil, I've got my magnetism has increased, and my over voltage switch will open, and now my field has to have this resistance added to it. That's going to drop field current. Field current drops. Armature voltage is going to drop. Armature voltage drops, and then this coil collapses and this switch closes again. So this switch is going to be vibrating back and forth, buzzing, just like any other over voltage switch. Take a look at over current condition. Erase all of our stuff here. So let's go look at an over current condition. Over current condition, again, all my current's coming out of my generator through this coil. This is closed out to the aircraft load. I've got an over current condition because, I don't know, maybe we've some kind of short circuit out here. When I get a short circuit out there, it's an overcurrent. My resistance here has decreased. In this overcurrent condition, now my magnetism here increases. When this magnetism increases, this is the switch contact for this coil. This one will open, and now my field has to go this way to ground. So basically, again, with an overcurrent condition, when I open this switch, I've added this resistance into the field circuit. Adding the resistance, field current decreases, field magnetism decreases, switch opens, decreases the output of the generator. So hopefully that helps you a little better understand how the 3-pole regulator works. I realize that modern generators all use solid-state electronics, but this same principle is exactly what is going to apply with any kind of solid-state regulator. Thanks for tuning in.